So in this case, we are going to consider a question based on the flywheels as we had those calculations, formulas that are needed. We want to see how to attempt now those typical questions. We are given 600 kilogram flywheel. All right, so that is the mass of the what? The flywheel that you're given, 600 kilograms. All right. And also is mounted on a shaft. Flywheel is mounted on a shaft where the shaft has a moment of inertia of the shaft has moment of inertia of 45 kilograms square meters. And we are asked to determine the diameter for one, a solid shaft. What is going to be the diameter? So remember, when dealing with a solid shaft, we stated that we are going to use this formula for the moment of inertia. All right. And as we can see, it is the one with R squared, capital letter R, for the solid shaft. So it means the moment of inertia of this is now taken as of the solid, where we are to calculate the diameter. So diameter is simply 2 times what? The radius. If we can have the radius, we are done. So the radius is determined from where we are going to take it from the moment of inertia of the solid shaft, which is half of m r squared. So this is the one that we need, the radius, so that we can determine the diameter. So how is that possible? Simply make it the subject of the formula or substitute your values. It is up to you. All right. You can make the subject. We're going to multiply by 2, then divide by what? By m. So it's going to be r is equal to, so multiply by 2, it's going to be 2 times a solid shaft. Then we're going to divide by what? By m. So take note, it was r squared. So to get rid of that, you must introduce the square root. All right, so r will be the square root of that, which is the square root of what? 2 times the moment of inertia for the solid shaft. We are treating this as of what? The solid shaft, the one that you're given, because they said as you take it as a solid shaft, everything over the mass, which is what? 600. So that was going to give us what? The radius, which is in meters. All right. So it was going to be something like 0.387 meters. But the diameter is what? Twice of that. So you see, guys, just a normal question that you are very used to. It's just a matter of doing more of the questions. You see that is just a repetition. So that's 0.774 meters. You can also express to millimeters if you want, or just leave it as it is. That is the case of your question. This is our case. So understand the question, all right, from the information. It's all about the information that you're given. The question is created out of the information. So just list down your information, go through the formulas. Then now we need the diameter for a hollow shaft. For a hollow shaft. If the inner radius is 250 millimeters, the inner radius, that's our small radius, 0.25 meters. So which diameter are we going to calculate now if we are given the smaller radius. Remember, a hollow section, it has two radii, the inner radius and the outer radius. So they want us to determine the diameter from the outer radius, since we are not given that outer radius. This is the case of our question. Remember, when we deal with a hollow section, outer radius, the inner radius. So that's how you're going to treat the question now. Because it is what? A hollow section. So that is, you are going to determine the what? You're going to determine the radius first. So remember, this is half of m into r squared plus r squared. So you determine the one that you're not given, which is this one. We are given the inner, so we must determine the outer radius. So this is our case. All right. How can we make this one the subject? Definitely, you were gonna multiply. So it was gonna be 2 times I. Then you divide by what? You divide by m. So after, this is no longer there. So you're gonna take the small letter r squared the other side. So it was gonna be a negative. Since it is r squared, you're going to introduce the square root to get rid of that. So that's r is equal to the square root of 2 times the moment of inertia of that hollow shaft over m minus r squared, just like that. So this is how we could have played around with the question, or you just substitute into the formula, then solve for r. There is one and the same. So r is equal to the square root of what? That's 2 times. We are treating the moment of inertia of the shaft, but we are treating as a hollow shaft now. So that's 45 over m. The mass is 600 minus the radius in meters. So our radius being what? 0.25. But we must square it, 0.25 squared, the inner radius. So this will give us the outer radius. So the outer radius was going to be 0.296 meters. So our question is not about the radius, but it's about determining what? The diameter, as we had in our previous question, 2 times radius. So that's 2 times 0.296. We're going to have a diameter of 0.592 meters. All right, so it is just direct as it is. You just need the formulas. It's application of formulas. Any other question, exam questions, that is, I think, the best that we're going to do. Work with exam questions from now, because it's just use of formulas. There's no need for me, guys, to be saying this other example. Let me just go through exams. So the next class is going to be exam questions, so that we can see how do they ask. But it's just a basic topic of all. It's a basic topic that you must expect in exam. So that is it till we meet again.